We were just a bunch of nerdy kids who ignored the haters. We took their ridicule and we built on it. And when some of us gave up, well, we built on that too. Built resilience, built on a mission to make things a little better every day until the users came. Then the haters were VCs who scoffed at our audacity. This just isn't the way things are done. But we kept building. Users turned into teams, turned into companies, running their entire businesses on our apps. Then the software giants came after us. We weren't proven, we weren't fully featured, our radical cloud model wasn't secure. But we built on. And today, as companies adopt the cloud to move faster, teams are finding themselves slowed down by each other's efforts. The skeptics are claiming we'll never develop innovation at scale. But now, DevOps have come to the cloud, ushering in a new era of transformation. Companies can release on demand across hundreds of environments, innovating faster with fewer conflicts and fewer disruptions. There will always be challenges. There will always be naysayers. And we'll build on.
So welcome everyone. As Amit said, my name's Dan Appelman. I'm the author of the book Advanced Apex Programming. And welcome to the return of the dark side of benchmarking. This time it's declarative. This course is a sequel to a session that I presented in 2016 along with Robert Watson, where we talked about CPU benchmarking in general. Today we're going to focus more on benchmarking and the declarative. So let's start out with a famous quote many of you are familiar with by the great author Mark Twain, who said, "There are lies, damned lies, and computer software benchmarks." Okay, I know purists among you might be thinking, wait a minute, there were no computers or computer software in the days of Mark Twain. However, I am certain that if Mark Twain was alive and around, this is what he would say, because computer benchmarking is really, really hard to do right. Unlike statistics where people lied by intent, with computer software benchmarking, even the people with the very best of intentions will often get it wrong because it's really hard to do properly. So we're going to talk about some rules of benchmarking. And the first rule is that because it's so hard, even if you intend to do it properly, anytime you hear of a benchmark, it is actually worthless and meaningless unless it's also presented with the methodology, when they show you how they did the benchmarking, so you can actually look at it critically and figure out whether they are doing things that make sense. And in fact, even though this is a session on benchmarking declarative, the real takeaway from this session is how to benchmark as compared to, oh, is process faster or flow faster or Apex faster? We'll have one example of that, but the real takeaway from this course is how do you go about doing it? So let's get started with some general rules and approaches that one should take. So let's talk first about the setup. We're going to be benchmarking operations that are based on DML, which is sort of common in processes and flows and so on. It all starts with a record change or a record insertion. So we're going to be working on basically data-related operations. And we're going to use a custom object. And the reason you always want to do your benchmarking on a custom object is because standard objects often have side effects. For example, if you insert leads, there might be internal deduping going on, and that could potentially consume CPU time and distort the results. So the only time you want to benchmark with a standard object is if you're really interested in the behavior of that specific object. Otherwise, stick with custom objects. Next, to start the benchmarking operation, you'll want to use anonymous Apex, and I'll show an example of this in a moment. I do not trust unit tests. Now, I am not going to tell you that you can't benchmark using unit tests, because it's been some time since I tried. Back when I tried, the results made no sense. So that's when I switched to anonymous Apex to do my benchmarking work. So it's possible that it's better, but I would tend to stay away from it unless you get evidence and are able to reproduce results in unit tests and anonymous Apex functions that match each other. Next, always test as many records as you can. The general way that you do benchmarking is you do 200 records and then divide the result by 200 to see how much time a particular record takes. And it's not only will you get more accurate results when you test as many records as possible, but this is why we need to do benchmarking in the first place. A process or flow or even Apex, you're not going to get a CPU timeout error if you're working with one record. The problem that we see in the industry is people build out declarative and code and build out functionality with one record, and then all of a sudden someone tries to do a data load of 200 records and everything blows up. So this is why we want to do another reason we want to do the benchmarking with as many records as possible. Next, anytime you do benchmarking, you want to do multiple measurements. So you don't just do one run and say, oh, that's my result. You actually want to do 10 or 20 runs, quite a few. And the reason you want to do this is because the systems are not stable, right? So for example, you might run a test at the exact same time that some other org on the pod is doing something incredibly CPU intensive, so the whole pod slows down a little bit. And that can have an impact. Or maybe you just happen to hit a time when the database is doing some internal cleanup work, or maybe there's a garbage collection, which is a computer science term for cleaning up memory. There are all kinds of reasons why a particular measurement might be faster or slower. So you need to average it out over multiple measurements. And what I often do is I'll do 10 or 20 measurements and I'll drop the best and worst case, thinking that those must be outliers. And if you do it that way, you'll find that they do tend to come in pretty close to each other. Another critical thing to remember is that capturing debug information consumes CPU time. So for example, if you're benchmarking Apex and you have your debug log level set to finest, most of your CPU time can actually be consumed by the debugging itself. What is it? The Heisenberg uncertainty principle, I think. It's the very act of measuring changes the behavior. So we're going to want to reduce the debug log information as much as possible. For Apex, we'll want to bring it to the error level. And for declarative, the info level, if we need to see it in the debug log, but otherwise set to none. And next, only test one thing at a time. You set up your system a certain way, you measure it, then you change one thing, you measure again, and that's how you determine the time needed for that one thing. So let's take a quick look at some code. Bring this up. And it's actually really simple. What I do is I create a class, because I could do this all in anonymous Apex, but it's easier for convenience to just create a class. And here's an example where all I'm doing is I have these test objects, I create 200 test objects and I insert them. It's as easy and simple as one can possibly imagine. And I'll call this from anonymous Apex. Here, however, is the way we're really going to do the CPU time measurement, which is we're going to create the objects, we will store the CPU time at this particular point in time, we'll do the insertion, and then we will debug output the difference between the current time and the previously measured time. And this is the way we can very, very accurately measure the CPU time of the insertion. Note that in the debug log statement, we're going to set the logging level to error. This is what allows us to set our debug log levels as low as possible. So let's go ahead and do this. I'm going to go ahead and bring up a developer console. Where's my developer console? Oh. I had it here a moment ago. Okay. This is because I'm on two screens. I know it is. But I'm going to get it back. All right.
Right now, we are able to see your VS Code screen.
Sorry?
I'm saying right now, we are able to see your VS Code screen.
Yes, but now you should see the developer console too, yes?
Yes.
Okay, I told you I'd find it. So what you do is you go to change log levels, and you create a new level, and I've already created here, called debugging. And note how it's set. The Apex code is set to error. And if I want to see the workflows and so on, I'll set it to info. Otherwise, I'll set it to none, just for measurement's sake. For this example, I'm going to leave it at info because I'm going to show you this log later. And the profiling you'll want to set to info level. So you select that. So now that's the, yeah, there it is. Oops. It's set to debugging as the debug log level. So we hit done. We bring up an anonymous Apex screen. Here you see anonymous.create object with measurement. We execute it. And this is the only one I'm actually going to show you because it just takes so long to do it. And here you can see there were the flows. And if I go to debug, ultimately, that's how much time was consumed in this particular run. Let me go back to PowerPoint. So as you can see, that's a right approach. I'm not going to say that's the right approach for benchmarking, but that is a right approach. Now, I'm not going to walk through and do any more of those live because we have such limited time available, but I'm going to go and show you some of the tests that we did. Okay, so the first test we did was a measurement with the first one, which was without measuring CPU time, just to see what the log looks like. And this was a completely clean org, no triggers, no nothing. And as you can see, it used no CPU time, right? Which at first thought makes sense because when they started measuring CPU time instead of script lines, they said DML operations, database operations would not count as CPU time. So this sort of makes sense. But it turns out that debug logs lie, because if you do the benchmarking with the measurement, you'll see that it actually consumes 48 milliseconds. So the idea that database operations don't use CPU time is not true. Sometimes they don't show up in the debug logs, but they do consume CPU time. And this 48 milliseconds, or about 50 milliseconds, is going to be our baseline, so that we're going to change one thing each time. And if we get a larger number, that tells us how much time that one thing took. So what we're going to try is an empty trigger, just to see if that has any impact. We're going to do a before update trigger, where we're setting a text field on each record to a constant value, a before update flow, which is the new feature in flows, a process, and a workflow. So empty trigger. I tested this quite a few times, and as far as I could tell, just creating a trigger with no code in it takes no CPU time that's measurable. So you can basically ignore that. So that's good news, because it means we can really measure what's inside of the trigger. When we did the Apex version, it came out to 10 milliseconds. So this is Apex code that is setting a field on each record to a text string, which is 50 microseconds per object, which is really fast. That's pretty impressive. When it came to a before insert flow, it took 30 milliseconds, which is 150 microseconds per object. Now, some of you might be saying, oh my God, flow is 3 times slower than Apex. We should use Apex. Or Dan Appleman's saying we should use Apex. No, absolutely not. What this does not tell us that you should switch to Apex from flow. What it tells us is that flow, before insert and before update flows, are really, really, really fast. And the difference between 10 milliseconds and 30 milliseconds on this kind of operation is so insignificant. We're doing 200 records here, that what this tells us is that at least when it comes to choosing between Apex and a before insert, before update flow, there might be good reasons to choose one over the other, but performance almost certainly is not one of them. They are both incredibly fast. But if anyone tells you that flow is faster than Apex, it isn't. Now, I'm not going to say there is no possible way. You might find one situation somewhere that flow is faster than Apex, but generally speaking, 99% of the time, the equivalent functionality, the exact equivalent functionality, will be faster in Apex than flow. So, but again, we're measuring one example here. Now go to process. Process is interesting. Process, keep in mind, this is not a before update. It's not a before insert or before update. This is actually doing another DML operation in order to do the update. So it's going to be slower, but 400 milliseconds slower? Well, that time is including both the process and the record update. Would a record update, we know that a record insert takes 50 milliseconds. Would a record update take 350 milliseconds? I don't think so. What you're actually seeing here is that processes are slow. And there is an article down here that you can look at that I talk about this more. And what's really taking the time is the criteria nodes seem to take a long time in processes. So processes, definitely there is a concern there in terms of performance. And this indeed we're seeing. People write a process, it works great, then suddenly they start processing 200 records at once and things are blowing up. And we're definitely seeing this all over the place nowadays. Now workflows are interesting, 40 milliseconds. That is insanely fast. And remember that workflows are doing an update. They're doing another DML operation, right? It's not a before update trigger. So how can workflows be so fast? And the answer is, I don't know, but I have a theory. I have a suspicion that 40 milliseconds there you're seeing is not actually the time of the workflow, but it's the time of the DML update. And I think that there's a very good possibility that they're not actually measuring the time of the workflow. So this is sort of gives a mixed bag, because it says, okay, well, if you can choose a workflow over a process for performance reasons, you might want to do that, but they could start measuring CPU time on workflows anytime without telling us. On the other hand, if they started doing that, probably a whole bunch of orgs would break up. So this is a little bit of a mystery, what's going on with workflows. All right. I also did a test with the flow plus the trigger. Remember the one that was 10 and the flow was 30, and it came out to about 40, which again is additional evidence that we're really doing a good measurement here. Now let's take a look at the debug logs of the flow and the trigger at the same time. So if you just do it unmeasured, the first anonymous apex that doesn't do measurements, we get 0 CPU time, which sort of sounds like, well, maybe we just didn't even hit the threshold for them to measure. But then when we did it with measurements, we got this. Now take a look at what we have here. First, we have the flow operating, and then it shows a CPU time of 2. Then we have the empty trigger operates right here. So the flow's up here. The empty trigger, it runs here. And the two of them together took 2 milliseconds. Then we have our field set trigger running, okay? And it takes, looks like 2 milliseconds. Then we hit the CPU time measurement, the debug statement, and it hits 92 milliseconds, and our total is 94. And you're sitting here saying, wait a minute. If you did not know what was going on, if you were just sort of a casual user, you would look at this and you would say, well, the flow took no time at all, 2 milliseconds. The empty trigger took no time at all, 2 milliseconds. Oh my Lord, this apex trigger consumed 90 milliseconds. So, the customer who's having CPU time issues will call Salesforce support, and Salesforce support will look at this and say, oh, this trigger took 92 milliseconds. And if this trigger belonged to, say, an ISV partner, right, they would call the ISV partner and say, your trigger took 92 milliseconds, and the ISV partner saying, I don't get it, I don't believe it. So what you're seeing here is that debug logs lie, and they lie in a way that severely distorts the truth of what is using CPU time. The 94 is accurate. About 40 of that is being used by the flow and the trigger, as we saw earlier, and about 50 of it is the DML operation itself. But because of the way that the debug logs work, it looks like the get CPU time operation, the act of measuring CPU time in Apex, of requesting that time, sort of sucks in all the time usage from everywhere, and then it appears in the debug log. So this is also one of the reasons that you'll often see that, that whatever Apex code happens to hit the CPU time limit at this point, that's what raises the CPU exception, and gets the error message attributed to that, and everybody blames that piece of code. So there is an idea on the idea exchange I point you to basically ask them to improve the debug log capability of measuring CPU time, both of declarative and of managed packages. So what are our conclusions here? Triggers are fast, and before update flows and before insert flows are fast. Workflows are effectively fast. They may be slow, but I don't think they're measuring it. And processes are dangerously slow. We know that debug logs lie. We know that benchmarking is hard, but if you're careful, you can gain some really amazing insights. For more information, I want to give special thanks to Keir Belden he did some absolutely pioneering work in terms of, he's the guy who figured out that the very fact of calling limits.getCPUTime sucks in the time into the debug logs. So this is a really great article there that he wrote on it, and thank you to him. And I also want to thank Robert Watson, who did the earlier work with me at the Dreamforce talk in 2016 on declarative benchmarking. So with that, I'm going to see, we've got a little bit of time for questions. I do want to say, if you take a look, here's the idea, here's the link to the idea, here's the link to sample code on GitHub, so you can use that as a basis for your own work. I've got like a few minutes. Let me see. Will this record it? I don't know. Chat popping up between sessions, I don't know. After checking debug log in the analysis panel, I noticed that 80% of the time was workflows. I moved some process builder to flow before save update, moved some send emails. Send emails can be costly as well. In fact, it's shocking how costly send emails can be, especially if there are templates involved in terms of CPU time. And they definitely cost even if they're called from a workflow. So even if some of the workflow logic may not be counted, if you start sending emails from workflows, I've definitely seen them counted. You have 44 reduced to 30. Do you think that combines with process and flow and use less if statements? What do I think about flow after summer 20? So I'm going to summarize what I can answer, which is the before update and before insert flows are really, really good. So definitely use them. For everything else, you now have the methodology to do your own benchmarking. So, and you can do this on your own system. So that's sort of my answer, right? I'm not going to try to answer specific things. What item would you set to see process builders and flows? You have to set the debug log level to info on workflow. Maybe, but this is an anonymous block which results I cannot explain. Don't use get time, get CPU time. Get time is elapsed time. It's not going to.
Sorry to interrupt you, Dan. We are running out of time.
So, to which I can say, if there are more questions, at Dan Appleman on Twitter, you can send me a message there. You can also send email is kibitzer@gmail.com, and send them on. What I can tell you though is I probably will not have a lot of answers because what I've been focusing is on the measurement methodology and not trying to come up with a whole library of how long different things take. So that's sort of my answer to that.